Okay, good morning. Welcome to
FamilyMath380a.
FamilyMath380a. So today, what did you guys do?
We built some Archimedean solids.
Okay, so what are Archimedean solids?
They are shapes that consist only of regular polygons. And they're made of only regular, the faces are only regular polygons.
The faces are only regular polygons. Okay, cool. What is this one called?
This is the truncated icosahedrodecahedron.
The truncated icosahedrodecahedron. That is a complicated name. What shapes does this one have?
So it is these decagons, the big one, this a square, squares and hexagons.
Okay, so let's figure out how many of each one there are. So what's the easiest one to count?
The decagons, they're big.
Okay, so why don't you tell me how many decagons there are?
Well, you can kind of think about it in layers. There's one, and this one, and then there's this ring here. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6. So that would be.
Can you talk just a little louder, please?
6. And then another ring. 7, 8, 9, 10, 11, and then 12.
All right, so there's 12 decagons. Okay, and we could see that just by counting them.
Yeah.
And now, what do you think is the next easiest one to count?
Well, actually, squares I think would be the easiest next.
Okay, so, but instead of counting them one by one like we just did, which is fine, we got to start somewhere with the decagons, can we make some sort of symmetry argument?
Well,
for how many, what are we counting, squares?
Squares.
Okay.
So I know there's 5 squares per decagon.
5 squares per decagon.
So there's 60. But then each square belongs to 2 decagons.
Okay.
This square, this one, and this one. So you have to divide by 2.
All right. So
30 squares.
So that would mean there are 30 squares. Okay. Cool. Did you understand that?
Yeah.
So each square belongs to, each decagon has 5 squares. So that means 60 total squares, except we count each one twice. So there's 30 squares. All right, so can you try to make the same argument for the hexagons?
So it looks like hexagons are surrounded by 3 squares and 3 decagons.
Okay.
And we know there are 12 decagons. So that would mean 36. That would mean but we have to see each of these is going to be used 3 times for, let's take this one as an example. So they'll be used for this group of 3, this group of 3, and then this group of 3.
Okay.
So there would be 12 hexagons.
Not quite. Not quite. Why don't you see how many hexagons there are around one of the decagons?
So 1, 2, 3, 4, 5.
Okay, so around each decagon there are 5 hexagons. So how many would that, since there's 5 hexagons and 12 decagons, how many would that be?
That would be 60.
But how many times do we count each hexagon when we do this?
3.
Okay.
So that would be 20.
So that'd be 20. Okay, good. Good job. So that's a nice way of counting. All right, so let's go on to the other 2 shapes.